Hello everyone, thanks for joining the APN Digital Summit. We hope you've enjoyed the presentation so far. Before we get started with our presentation, we want to go over a few housekeeping items. First, this session is being recorded. We will send you the recording when the presentation is over, along with the additional information to help you continue learning more about these services. If you do have questions during the presentation, please add them to the question window. We will do our best to answer all the questions as they come in, but if we don't, we will follow up in an email after. If you're having any audio issues, try using your computer's mic and speakers. This usually fixes the problem. Thank you again for your time today. I am now going to pass it over to our presenter.
Hi, I'm Eric Duran, a Senior Manager of Storage Business Development here at AWS, and today we'll be spending the next 45 minutes to an hour talking about AWS storage services and how to help customers choose the right storage service for their workload. In this session, we will be reviewing the portfolio of AWS storage services, discussing some key examples of storage-centric workloads that customers are building on the platform. We will discuss how to choose the right storage service for each workload, providing what considerations should be made when selecting the right storage services when migrating or building application workloads. We will also review customer examples for each of these workloads or applications. With the elasticity of AWS, you no longer need to forecast demand or buy upfront. You get the ability to scale up to meet the needs of spiky workloads, but then give that capacity back when the spike is over. Whether you're dealing with annual spikes like a December retail boom, monthly or quarterly spikes associated with accounting workloads, or unpredictable spikes associated with web marketing or any other situation when demand changes over time. Cloud has considerable advantages over the traditional IT investment model. This elasticity model is particularly beneficial to customers in the context of storage, preventing customers from having to make large capital expenditures upfront, constantly managing capacity for application workloads with changing data growth patterns, often leaving customers with inadequate or even worse, excess capacity for their on-premises storage arrays. Instead, with AWS storage, you can just pay for what you use when you need it as application and business needs change. AWS storage is the best at helping customers get more value from their data faster. It is a foundation for advanced innovation, and customers start finding value from the moment they move their workloads to the cloud. AWS storage often accelerates customers' business transformations like this. First, customers build a new application or migrate an existing one to AWS, leveraging our offerings for development or application discovery, tracking, and movement. AWS has the most options for moving data in the industry, and we'll touch on more on that later. Next, once their data is in the cloud, the reliability, security, and management capabilities only found with AWS kick in. AWS has more compliance certifications than any other vendor and more third-party partners than can be found anywhere else or on any other platform. With their data on the platform, customers can build with AWS using the services and features that pull insights from this data at scale. Customers like Infor that work with thousands of Microsoft SQL databases, or FINRA that plays back the US stock market in real time, or Monsanto that has moved petabytes of geospatial analytics to the cloud. Finally, customers also, once they move their data, also develop new cases to transform their business. Sony DADC cut media workflows from weeks down to hours. iRobot is mapping connected homes with millions of robots without managing any servers. Sprinklr can recover thousands of servers and petabytes of data in another global region in less than 4 hours. And SiriusXM took a small custom application acquisition to global production at scale in less than 90 days. So why choose AWS storage? Well, there's 6 main reasons customers tell us they choose AWS as the foundation of their future innovations. The first is reliable operations and scale. No other cloud vendor has the experience that comes from earning the trust of millions of customers for more than a decade. Gartner has stated that The scale at which AWS operates its public cloud storage services dwarfs the other vendors in this Magic Quadrant. All AWS services run in at least one of 18 global regions, which by default include multiple availability zones made up of multiple discrete data centers. This design protects against natural disasters and means data with AWS is never stored in a single facility by default. It also means that data can be replicated between any combination of regions to meet performance, governance requirements, or disaster recovery needs. Customers like Sprinklr use this infrastructure to demonstrate audit compliance by bringing up their entire environment in another global region in under 4 hours. FINRA relies on the scale to deliver trillions of records to keep pace when stock markets spike. And Spokio serves billions of files from a single elastic file system. Next, we offer the most comprehensive and granular security and management capabilities. AWS Storage helps customers retain absolute control over their data. They can choose from places around the globe. They can automatically secure and encrypt file system, volumes, and objects using their own keys or the AWS Key Management Service, or KMS. Companies like Pinterest, ProtectWise, and Infor lifecycle data between storage tiers to address cost, performance, and availability to build data lakes, analytics, and backup solutions. Proofpoint uses Amazon Glacier Vault Lock to help meet long-term compliance requirements. Organizations of all kinds monitor, automate, and track actions by user or application with AWS CloudWatch and AWS CloudTrail, and can classify and visualize this behavior in Amazon S3 through Amazon Macie and AWS QuickSight. And AWS has the most security standards and compliance certifications, such as PCI DSS, HIPAA, FedRAMP, attestation for SEC Rule 17A-4, the EU Data Protection Directive, and FISMA. This wide range of capabilities is partly why organizations like the US federal government say they can operate more securely in the AWS cloud than in their own data centers. We also offer the most complete portfolio. AWS storage services are the only offerings with durability, redundancy, and price points for all kinds of architectural requirements, and can integrate seamlessly with in-house or third-party applications. No other vendor helps customers move large amounts of data through as wide of a range of migration services, including hybrid on-premises devices, content delivery networks, and physical transport devices. Organizations like Live Nation, SmugMug, NASDAQ, and Digital Globe report that the combination of multiple storage protocols and interfaces with large-scale data transfer options helps them simultaneously shut down data centers, migrate their applications, and develop for the cloud to accelerate their IT projects. We have the most supported platform with the largest ecosystem. In addition to integration with the most AWS services, AWS Storage has twice as many technology partner integrations than any other vendor, tens of thousands of consulting, system integrator, and software vendor partners, with more joining every month. And the AWS Marketplace offers 35 categories and more than 3,500 software listings from over 1,100 independent software vendors, or ISVs, that are pre-configured to deploy on the AWS cloud. This means that customers can easily use AWS Storage with popular storage and data management solutions, including NetApp, Cloud Endure, Commvault, Veritas, Dell EMC, and IBM, enterprise applications, including Oracle, TIBCO, Atlassian, Informatica, SAP, PeopleSoft, and VMware, and big data analytics frameworks and databases like Hadoop, Microsoft SQL, and Cassandra. We also offer the most comprehensive support and consulting. Enterprises like News Corp, Unilever, and Pitney Bowes have used AWS's experience and knowledge to plan, deploy, and optimize with confidence. Training, support, and services from AWS help these customers shift teams from troubleshooting outages into developing and delivering the next revenue-generating applications. AWS training gets teams ready to operate in the cloud, and with AWS ProServe consulting services, along with the widest range of technical consulting partners, customers can get the help they need migrating and building their applications, with while AWS support plans to help them with escalations once they move. So we offer the most complete, AWS storage services offer the most complete set of building blocks. These building blocks offer the foundation of storage services with analogs for on-premises storage services like block or storage area networks or SANs, file or network attached storage or NAS, and object and archival storage. As mentioned, we have the widest range of data movement choices, including hybrid, streaming, file sync, WAN acceleration, private networking, third-party application, and physical appliances, depending on what your need is to move the data. AWS offers the best-in-class data security and management services and features, including data discovery and protection, data visualization, serverless computing, automation, audit trails, monitoring and metrics, access controls, and of course, encryption. So at AWS, we spent years listening to customers, understanding their foundational technology and tools that they need. And our storage service portfolio, seen here, is based on that input. They've asked us to really help in three main areas. The first, starting on the left, is moving data. Applications without data are not very useful, and there are many ways to address each customer's problem. So this can include hybrid solutions like the AWS Storage Gateway, or online services for moving data like Kinesis, File Sync, Direct Connect, and for those large bulk transfers, we offer offline physical transport options like AWS Snowball and the AWS Snowmobile. In the middle, we have core platforms that offer the right application interface, performance, and cost dimensions based on the application requirements, including Amazon EBS for block, Amazon EFS for file, S3 for object, and Glacier for archive. And on the right, security and management tools to ensure that data is protected to help automate processes, generate alerts, and synchronize data with other AWS services. Many companies around the world choose to rely on AWS storage. What we build is driven by the customer and has resulted in tools that work for industry disruptors like Airbnb, Uber, and Ring, but also enterprise IT teams at GE, Toyota, and governments around the world. AWS storage has an advantage because of more than a decade of experience. We see the semantics of block, file, and object as a starting place and help customers build experiences on those. That means we're constantly redefining what these types of storage mean in the cloud. For example, Rio Tinto is using our storage appliances to build smart trucks that collect data while operating in harsh environments to analyze in the cloud and improve mine efficiency. And that's provided a whole new way for them to think about using data in their business. Working with customers over the past decade plus, we've seen customers building a core set of storage-centric applications. This includes backup and recovery, often one of the first workloads that customers migrate to the cloud due to it being non-disruptive to their existing processes, as AWS storage is integrated with all the major backup vendors. Next, we see customers migrating their legacy archive data and building active archive solutions for media workflows or other types of data, replacing the management of physical tape and deriving new insights from their archives. We also help customers in the public sector, financial services, and healthcare life sciences achieve fully compliant archives. Next, customers are building data lakes and IoT workloads, leveraging streaming data and data visualization services to analyze their data faster. Finally, we also see customers lifting and shifting their existing databases and applications to take advantage of the cost and management efficiencies of managed platform services and focus on their business's core competencies. So what do you consider when selecting a storage type? Well, when evaluating and migrating or building a new application, consider the underlying storage type is a foundational decision for each application architecture. There are three primary considerations for this decision. First, in particular when migrating an existing application, identifying the semantics associated with the underlying storage is critical. Does the application require block, a file interface like NFS or SMB, or a RESTful API, such as would be found with object storage? What are the performance requirements? And if migrating, does the current storage type meet those requirements? What features and compliance needs does the workload have? And finally, what economic requirements or constraints does the application have? Answering these questions can determine what storage service, or in most cases, mix of storage services that are required for the application workload need. So first, let's discuss the storage types that need to be considered. Starting on the left, in a file system, data is stored natively as files with a hierarchical directory structure. Each file and directory has particular metadata associated with it, things like its owner and creation time. In an enterprise context, file systems store data that can be accessed over a network by multiple clients at the same time. You can think of it like network-attached storage, or NAS, found on premises. In a block store, you have a set of disks, usually locally attached to a single computer. Data is stored in chunks on these disks called blocks. Operating systems will work with block storage by presenting its data in a file system format to users and applications, with the underlying raw data being stored as blocks. You can think of block storage like locally attached disks, or a storage area network, or SAN. And last but not least, on the right, we have object stores. Here, data is stored in a container called an object that is identified by a unique key and stored without any sort of hierarchy. Object stores provide a simple API to get and put data based on its key, and this API is commonly accessed over the internet. As a refresher, these three types of data map to the core AWS storage services: EFS for file, EBS for block, and S3 and Glacier for object. The next aspect to consider is the performance of the storage solution. So here on the x-axis, we have latency, and on the y-axis is throughput. Block stores generally provide the lowest latency, but don't scale the amounts of throughput achievable on file systems of object stores. Some example of workloads that require low latency and relatively low amounts of throughput are certain database applications and boot volumes, especially where access is only needed from a single computer at a time. Moving to the right, file storage is generally designed for low, consistent latencies, but also is designed to scale to tens of gigabits per second of throughput. And finally, object storage provides the highest levels of throughput scalability, but isn't designed for latency-sensitive applications. An additional consideration is the durability requirement of the application data. S3 standard object storage classes replicate your data across 3 availability zones within a single region. AWS availability zones are always miles apart, never in a third-party colocation facility, and of course, never defined as a single room or a partial rack. This gives you unmatched resilience to single data center issues like power failures and helps us deliver that 11 nines of durability. Sometimes your data just doesn't need this. In that case, for easily recreatable or data or backups, we offer a new storage class called S3 One Zone Infrequent Access. This helps you reduce costs in backup or replication scenarios. For different use cases, EBS, the Elastic Block Store, is also designed as a single AZ storage type, offering better performance and lower latency than region-level storage services. Next, let's dive a bit deeper into each storage service and its key features. The first storage service we will review is the Amazon Simple Storage Service, or S3, our industry-leading object storage service. There's no better choice for object storage than Amazon, and here's why. We have unmatched durability and scalability. Amazon S3 was built from the ground up to deliver on a customer promise of 11 nines of durability. Data is automatically distributed across a minimum of 3 physical facilities that are geographically separated by at least 10 kilometers within an AWS region. And Amazon S3 can also automatically replicate data to another AWS region. We offer the most comprehensive security and compliance on the for S3. Amazon S3 is the only cloud storage platform that supports 3 different forms of encryption, including automatic server-side encryption, encryption with keys managed by the AWS Key Management Service, or KMS, and encryption with keys managed by the customer. S3 offers sophisticated integration with AWS CloudTrail to log, monitor, and retain storage API call activities for auditing. Amazon S3 is the only cloud storage platform that includes Amazon Macie, an AI-powered security service that continually monitors the use of your data to detect anomalies, then issues alerts to you that you can take action on to prevent data loss or inadvertent sharing of data. Amazon S3 supports more security standards and compliance certifications than any other offering, including PCI DSS, HIPAA, FedRAMP, SEC Rule 17a-4, the EU Data Protection Directive, and FISMA, helping satisfy compliance requirements for virtually every regulatory agency around the globe. This level of protection helps highly regulated organizations such as Capital One and the United States federal government operate more securely in the AWS cloud than in their own data centers. We also offer query in place for analytics needs. So Amazon S3 is the only cloud storage platform that lets customers run sophisticated analytics on their data without requiring them to extract and move the data to a separate analytics database. This means that anyone who knows SQL can use Amazon Athena to analyze vast amounts of unstructured data in Amazon S3 on demand. And with Amazon Redshift Spectrum, customers can run sophisticated analytics against exabytes of data in S3 and run queries that span both the data you have in S3 and in your Redshift data warehouses. So what do customers use S3 for? We see customers using S3 as a foundational component to build for use cases like backup and restore, as the foundation for their data lakes and IoT, as well as analytics, and for building cloud native applications. So next, let's look at Amazon Glacier. Glacier is the most cost-effective way to store data for archive and long-term backup. It's ideal for active archive, tape replacement, and regulatory compliance use cases. Glacier is built on the same highly durable infrastructure as S3, but with a focus on long-term archival use cases. The Glacier Select API extends a data lake with a colder tier for data and lowers the cost of storage while opening archive data up to on-demand analytics queries. And data can be accessible in minutes through expedited retrievals. So customers are typically using Glacier for their active archive repositories, as well as the foundational storage component for building compliant data archives to meet their business regulatory requirements. So to summarize the AWS object storage portfolio, we offer 4 classes of storage, optimizing for cost as data gets colder, moving from the left to the right. The most active data, or warmest data, first is stored in S3 standard. As data gets colder or is accessed less frequently, it can automatically be tiered to a colder storage class, such as S3 standard infrequent access or S3 one zone infrequent access, via an automated lifecycle policy that moves data in the same bucket based on its age according to the parameters a customer specifies. Finally, data can automatically be archived to our coldest tier, Glacier, via an automated lifecycle policy. This tiered structure enables customers to balance access time to their data with the cost of storing data according to the application or business requirement. Next, let's take a look at Amazon Elastic Block Store, or EBS, the AWS storage service for block-based workloads. EBS provides dedicated, detachable volumes that are local to EC2 instances, offering the lowest latency, highest performance storage for their applications. EBS volumes enable customers to migrate existing applications without re-architecting and can be adjusted to various price and performance characteristics to meet the application need. This design helps customers address workloads that benefit from fine-tuning for performance, cost, and capacity. So typical use cases for EBS include big data analytics engines, such as the Hadoop ecosystem or running Amazon EMR, relational and NoSQL databases, including SQL Server, MySQL, Cassandra, and MongoDB. We see customers using EBS for log processing, including Kafka and Splunk. And finally, we see customers using EBS for data warehouses, including Vertica and Teradata. And to round out the core storage portfolio, let's take a look at the Amazon Elastic File System, or EFS, the AWS storage service for file-based workloads. So EFS is the first fully managed NFS-based cloud file system built from the ground up for file sharing between EC2 instances. In the past, you had to own and operate a NAS array or build and manage a file system using a third-party software package on top of EC2 and EBS. EFS is fully managed, so we take on all of the management around capacity and compute, allowing for a truly elastic storage experience. It's so simple to use EFS that you can mount multi-petabyte shared storage on EC2 instances in minutes. EFS automatically grows elastically and shrinks as you add or remove data, allowing customers to only pay for the capacity that they need. It keeps consistent performance as your data scales, and it can connect to on-premises hosts as well as EC2 instances in multiple regions. Like its object storage counterparts, EFS stores data redundantly across multiple AZs in a region by default. So we typically see customers using EFS for use cases like web serving and content management, enterprise applications, media and entertainment processing workflows, user home directories, database backups, developer tools, container storage, as well as big data and analytics applications. So now that we've looked at the core AWS storage services and made a determination to identify the right storage for the customer's workload, the first challenge for organizations comes down to the physics of moving that data. So based on feedback from customers, we have built services to help with things like data center shutdowns, managing data at remote sites, migrating existing applications, as well as building hybrid workflows that can still accommodate on-premises data. So AWS data transport options come down to three types: connected networks, physical device shipping, and hybrid deployments with on-premises environments. To dive a bit deeper, for network-based options, we have several options ranging from dedicated private network connectivity with AWS Direct Connect, WAN-optimized data transfer over long geographic distances with Amazon S3 transfer acceleration, easy accelerated file system transfers with Amazon EFS File Sync, and managing streaming data into S3 with Amazon Kinesis Firehose. For customers with very large petabyte or even exabyte scale, we offer services for bulk data migrations with the AWS Snow family, including the AWS Snowball appliances, Snowball and Snowball Edge appliances, as well as the AWS Snowmobile for very large capacity needs. Finally, for integrating into on-premises environments, we have third-party software offerings through APN competency partners and the family of AWS storage gateways, enabling easy integrations for backup, disaster recovery, tiering, and data migration needs. So before we jump into some customer examples, let's take a look at how the storage services we just reviewed map to the storage-centric workloads we discussed earlier. While every use case can be different, these are the AWS storage services we typically associate with each solution. For backup and restore, we see customers adopting S3 and Glacier, and in some cases, EFS, migrating data with third-party software, Storage Gateway, and Snowball. For Active Archive, we see customers adopting S3, specifically S3 and Frequent Access, and Glacier with the bulk and expedited retrieval options. For data lakes, we see customers leveraging the low cost of S3, using Athena and Redshift Spectrum for analytics, directly extracting data from S3. For data lakes and For data lake and analytics workloads with NFS requirements, we see customers adopting EFS. And for those with on-premises data lake scenarios, we see customers extending their storage capacity with tiering to the storage gateway. For compliance storage needs, we see customers leveraging S3 and Glacier, leveraging Glacier's vault lock feature for write once, read many, or worm compliance needs. For database and analytics, we see customers taking advantage of the low latency and performance of EBS volumes with EC2. And finally, for migrating existing enterprise applications, we see customers leveraging EBS or EFS based on their block or file storage requirements. So let's take a look at a few customer stories. For our first customer use case, we're going to look at how StemCell took advantage of migrating their backup and restore environment to AWS using our storage services. So StemCell is Canada's largest biotech company with 10 worldwide offices, and they develop and manufacture products for cellular research. So they had a challenge with data sovereignty requirements required them to keep a long-lived archive in all 10 individual offices that was based on tape. And they wanted to eliminate this undifferentiated work and focus on their primary business, science. So with AWS, they were able to leverage the AWS storage gateway, specifically the cached volume variant, to provide per office scalable local storage. And what this enabled was all offices were able to store their data on AWS in appropriate regions using the gateways. They were able to eliminate backup and archiving being done in each office, and instead were perform that with the data being stored in AWS. The result of this is it eliminated a 50-hour backup window, and it dropped their recovery time objective from 48 minutes to 10 minutes. The net benefit was this enabled them, eliminated the need for new on-premises storage purchases, reducing their CapEx expenditures by 40%, even with exponential data growth. They were able to implement a 12-month data center exit plan, and this resulted in their teams focusing on their core business and not on storage management. Next, let's take a look at an active archive example. Sony DADC provides a managed service to support media distribution through over-the-top and linear playout to their media customers. Their venue solution enables managed services involving rights and availability management, content aggregation management, distribution, authoring, linear playout, as well as over-the-top video. So they were looking for a cloud-first strategy to overcome some of their on-premises infrastructure limitations. And with over 20 petabytes of content under management, which equated to 800,000 hours of video available on their platform. Migrating to AWS has provided them with better scale, economics, and performance, and ultimately allowed them to decrease their customers' content distribution time to market. So with S3, they were able to improve their TCO with taking that 20 petabytes from on-premises and moving that into S3 and Glacier. And they were also able to improve their customer experience by reducing the time it takes to produce customer content from what was previously weeks while on premises to now less than an hour. Our next example is AlertLogic, who is leveraging S3 as the foundation for their data lake for their software as a service security solution. So AlertLogic is a SaaS provider with more than 4,000 customers and 25 petabytes of customer data, growing at a rate of 110% per year. So they started out by building their infrastructure in a co-location facility and began to have challenges when they got to cloud scale. The co-location approach was slowing them down. It was too expensive, it was not agile enough, and they had to deal with undifferentiated heavy lifting. Basically, they had to manage all of that infrastructure, and they found this to be unsustainable for their business. So with moving to AWS, they were able to become more agile, cost-effective, and could scale as needed, all the basics of what you get moving to the cloud, but more so using S3 unique management features like object tagging, S3 inventory, storage class analysis, lifecycle policies, and cross-region replication. They began to understand their customers' data in ways that help them improve costs optimize performance, as well as meet their specific compliance requirements. So the net value to AlertLogic was it reduced their fully burdened storage cost, which in their case included the data in S3 Glacier, as well as replicated in 2 disaster recovery regions, to less than 1.7 cents per gig per month, which was less than half of their co-location costs. It also enabled them to avoid a $1.6 million CapEx expenditure in the first year, and they are now able to game day test at 100 times their expected load. This was impossible in their previous co-location model, as they would have had to purchase all of that equipment. The net of this has increased their agility by repurposing all of their people into a pure DevOps model for development. Let's also look at an example of a regulatory compliance workload on AWS storage. Proofpoint, which is a social media platform, or social media regulatory platform for corporate customers, they control and enforce over 1 million daily social media posts on behalf of their corporate customers. With the Vault Lock feature on Glacier, Proofpoint was able to offer their customers a fully compliant SEC Rule 17a-4F compliant archive, offering for a fraction of the cost to do so with on-premises infrastructure, complete with a 2-step legal hold with vault level tags. The net here, and I love the quote of this one by Rich Sutton, is on-premises solutions that satisfy the SEC Rule 17-A are extremely costly, and this is a feature that customers are able to take advantage of at no additional cost on the Glacier platform. Next, let's look at a database and analytics workload. So in this case, let's take a look at ProtectWise. ProtectWise is a threat detection company capturing and analyzing network security data that identifies patterns and problems. And so their time to detection is central to their business success. The more data they have to analyze, the better the results they can produce. So they had a challenge with data ingest growth, which was outpacing their ability to both index and search the inbound data. And storage growth was frequently requiring resizing of their Cassandra cluster, often taking weeks at a time. So all of this was impacting their ability to take the data collected and turn it into a business result for their customers. So with AWS, ProtectWise was able to decouple the storage from compute, leveraging EBS volumes. They could keep up with both the ingest growth and building their indexes as needed. Additionally, they decided to re-architect the way that they stored their index data into an S3 data lake, optimizing for cost as well as for scale. By combining the high-speed indexes on EBS with the highly parallel retrieval speeds from S3, they were able to achieve near limitless growth of the data set and maintain consistent search performance. So by decoupling storage from the compute, this increased their agility, and indexing went from weeks down to hours. EBS resulted in a 30% cost savings, and the new a 95% cost savings combined with S3. And this new architecture resulted in a consistent 1 to 3 second search response time, even as their data sets have continued to grow. And finally, lowering the time to detect over larger and larger data sets is core to their business, security. Our final customer example is from SiriusXM, a satellite radio provider who streams more than 400 radio stations and has over 32 million subscribers. So SiriusXM had acquired a company that had a streaming media product that depended and had been architected on a local file server solution. So the challenge was, as part of this application, the SiriusXM development team had 90 days to integrate and ship this new partner streaming service to their customers. The issue was that the partner's device software was built on a single server with local storage, so a fairly basic solution, and one that certainly wouldn't scale to their very large customer base. So they needed to find a way to scale this with minimal change. They considered building their own NFS file system on AWS, and then realized that building this all themselves from scratch in 90 days just was not feasible for the time allotted. So With AWS, they found that they were able to use EFS, which effectively amounted to an easy button. While they had 90 days, leveraging a fully managed NFS file system, leveraging EFS, it took only 2 hours to implement the solution. So the combination of EFS and EC2 autoscaling gave them the agility they needed to launch well within their 90-day window. And so also love their quote here, they were looking for good and fast, but they got good, fast, cheap, and reliability and scalability all in significantly less time than they had planned. So wrapping up, in this session, we've reviewed the portfolio of AWS storage services. We've discussed some key examples of storage workloads that customers have built on the platform. We've discussed how to choose the right storage service for each workload, evaluated what considerations should be made when selecting the storage service, as well as discussed how to migrate, options for migrating and building application workloads on the platform. We've reviewed customer examples for each of these workloads. So this webinar was really intended to be a primer for what storage and data migration services are available to you and your customers. And we look forward to working with you to help our mutual customers adopt the right storage solution for their needs. Thank you for your time and attention, and we will now move on to questions.